The world's atmosphere is being poisoned. Every day, pollution on a massive scale is being released by man-made carbon dioxide gas from thermal power stations. Nuclear power is thought to be a solution, but it still comes at a cost. It is prohibitively expensive to build, dangerous to operate, and creates its own unique pollution. Humanity needs to take strides in reducing the amount of pollution we release into our natural world in order to stop and reverse the devastating and increasing effects of climate change, and to secure the future for generations to come. The global challenge, which Truic Marine believes is attainable, must put a stop to increased production of electricity which creates CO2 or nuclear waste, protect Earth's finite resources, and replace over time those power stations currently producing CO2. Truic Marine believes that they have a solution that goes some way to help achieve these three key objectives. They have designed a non-polluting, sustainable, offshore power station which harnesses the recurring power of the tide. They are now looking to secure investment to continue their research and development, which will result in a full-sized, fully operational power station. It is expected to cover an area the size of a football pitch, and unlike current nuclear power stations, the majority of materials used in its construction will be recyclable at the end of its commercial life. It will house an array of generators that are driven by giant, high-torque, low-speed impellers. These impellers will be positioned under the surface of the water, housed in cowlings which rotate to face the tide. They are likely to be 10 meters tall and have a diameter of 6 meters. The Truic Marine tidal power stations will have three key advantages. The generators and all the electrical assemblies are housed within a dry, accessible and warm building, which enables maintenance and operation to be carried out easily, safely and at a relatively low cost. Each of the impellers is mounted on a bearing that has a rudder which allows the whole impeller assembly to rotate with the tide, allowing them to work as efficiently as possible and with little or no input from an operator or computer system. And, unlike wind or solar power, tidal flows are guaranteed, which makes this form of energy generation one of the most cost-effective forms of sustainable electricity. To realize these advantages, Truic Marine has identified a three-stage approach to prove the viability of the concept. Stage 1. Research and modelling. The process begins by researching and testing the impeller design by using scale models in university hydrodynamic testing facilities. These tests would determine the size and output capabilities of a full-sized single impeller. Based on this data, Truic Marine could then calculate the number and size of generators required for a commercial power station. The cost for this stage is in the region of £2 million. Stage 2. Manufacture and proof of concept. At an approximate cost of £5 million, a full-sized working impeller could be manufactured, coupled to a generator and positioned in a tidal flow. The goal will be to prove the electrical output of this prototype and confirm the size and number of generators required for a commercial power station. To withstand the tidal forces which will be acting on the impellers and to support their size, they are likely to be manufactured from alloys similar to those found in the propellers of ocean-going vessels. Stage 3. Build. As the generator and impeller assembly will have been proven by this stage, Stage 3 is all about the design and build of a full-size, fully functioning tidal power station. This will be completed for a multi-million-pound cost and hopefully will be the forerunner for many more around the world. Today is the day that we need to act, so please contact truicmarine@gmail.com for more information about investment opportunities to help save our planet.